class, this is section 5.2. We are going to look at the exterior angles of polygons. So, first thing I'd like for you to do is open Sketchpad, and we're going to construct any polygon. Then after you construct a polygon, extend each side so that there are exterior angles of each angle of the polygon. Then I would like for you to measure them, and then we'll talk about the definition of equilateral and equiangular. So, opening Sketchpad. We can construct any size polygon. Okay, now we want to extend each side so that there is an exterior angle for each angle that is here. So I'm going to highlight these 2 points, and then I am going to construct a ray, and I will do that at each vertex of the polygon. So the angles that I've just made are called exterior angles. Notice that they are adjacent and supplementary to the interior angles. So what I'd like for you to do now is measure each one of these exterior angles. Let me highlight it. So I'm going to have to put points on here so that I can measure the angle. So I'm highlighting the angles that I want to measure. Okay, so all of my exterior angles have been measured. I had 5 vertices, so there are 5 exterior angles. Okay, I can move them, I can change it around. Now what I'd like for you to do is sum your angles, the exterior angles. So I'm going to go to the calculator. I'm going to click on the first exterior angle, then I'm going to say plus, and then I'll go to the next one, and then hit plus, and so I add all 5 of them together. And look what happens. Mine summed to 360 degrees. Do yours sum to 360 degrees? I certainly hope so. So if I move my angles, notice the sum is not changing. Even though the values over here are changing, the sum is not changing. So from this information, do you think that you can write a conjecture about the exterior angles of a polygon? I certainly hope so. So I wanted to take a picture of this and put it into your notes. Okay, so the exterior angles sum to 360 degrees. We will write a conjecture. I'd like to show you another demonstration of the same theorem. So here is a polygon. Look what happens if I shrink it. What does it make? A circle. And we know that there's 360 degrees in a circle. Okay, I'm going to make it so it has one less side. I'm going to go ahead and show the sum. It doesn't matter if it has 5 sides, 4 sides, or 3 sides. The exterior angles will always make a circle, which means that the sum is always 360 degrees. Okay, so back in our notes, we now have a picture to go along with our conjecture. We have done that. So the exterior angle sum. For any polygon, the sum of the measures of a set of exterior angles is 360 degrees. Okay, so fill in your blank. This is conjecture 32. This is section 5.2. If you'd like to label your notebook that way. So 360 degrees. We have one more conjecture that I'd like to talk about. Equal angular polygon conjecture. So I told you that we were going to talk about equal angular and equilateral definitions again. So equilateral so an equilateral polygon is a regular polygon, which means all of the sides and angles are congruent. So if we're talking about an equiangular polygon, it's going to make things a little bit easier to solve. So you want to make sure that you pay attention to see if it's equilateral or equiangular. So you can find the measure of each interior angle of an equiangular ingon by using this formula. Now, it's a little bit harder to draw that in Sketchpad when it's equiangular or equilateral. So I am going to just draw a picture of it for you, and we're going to talk about what that means. Okay, so here's our picture. I am going to make an equilateral hexagon. Okay, so I know from yesterday's conjecture that if I want to find the sum of the interior angles, that all I have to do is take 180 times n minus 2. So I replace my n with 6 because I have 6 sides. So that means 180 times 4, which gives me a sum of 720 degrees. So that means if I take angle 1, 2, 3, 4, 5, and 6, they will sum to 720 degrees. Now, but because this is equal angular, that means that all of these angles are congruent. So if the sides are congruent, the angles are congruent, it is called a regular hexagon in this case. So because they're going to be divided evenly, at this point then, if I want to find the measure of any one of the angles, what I have to do is take 720 and divide it evenly by 6. So that means each angle of my hexagon, regardless of the length of the sides, is going to be 120 degrees. So, if I wanted to do that for any n-gon, the formula that I would use is 180 times n minus 2, but then I want to divide that by n. That's exactly what I did here. Okay, so my n was equal to 6. So I took 180 times 6 minus 2 to get the 720, and then I wanted to divide it evenly. So each one of my angles is 120 degrees. Now, if each one of my angles is 120 degrees, what's the measure of each one of my exterior angles? So if I extend the sides, I'm forming my exterior angles. They're a linear pair. So 180 minus 120 gives me each one of these exterior angles to be 60 degrees. Okay, so if I wanted to find the interior angle, I could take I know the sum of all my exterior angles is 360. I could divide it by 6 to get 60 degrees for my exterior angle. And then take 180 minus that value. So then 180 minus 60 gives me 120 degrees for my interior angle. So there is 2 ways of solving for an interior angle measure when it is a regular polygon. So there's the first one. The second formula will be 180 minus 360 over n. Again, n is the number of sides. Of my regular polygon. It is regular. Okay, it only works for regular polygons. So if we do one more example, let's say we have a regular pentagon, since we've already talked about pentagons. My exterior angle measure this is of one angle. We know all together they sum up to 360. Well, if there's 5 sides, 360 divided by 5 will give me 72 degrees. So one interior angle measure of one angle will be the supplement to 72 degrees. So 180 minus 72 degrees leaves me with how many? 108 degrees. So my interior angle measure of any regular polygon is 108 degrees. The exterior angle measure is 72 degrees. If I'd like to use the other formula, I would take 180 times n minus 2 divided by n, where n is 5 in this case. So 180 times 3 over 5. So I'm going to divide 5 into my 180 first. So that goes 36 times 3 to give me the 108. So either way that you'd like to solve those is fine by me. Just make sure you're comfortable whichever method that you choose. See you in class tomorrow.